we said that y was equal to 343 divided by x. That means y is 343 divided by the square root of 343, and I'm almost sure the book's not, or the computer wants you to rationalize this, so I'm going to multiply top and bottom by root 343. And what happens is on the bottom, you multiply these two together, you get 343, and then that 343 on the top cancels with those, and then all you're left with is square root 343. So your y is 343. All right, notice root 343. So notice your x and y's are the same value. It's not always going to work out that way. It's just these examples to start off are kind of basic. So your answers often turn out to be the same. All right, let me see. Make sure. Let's see how much they show you here. Yeah, well, okay. Do they ask for find the dimensions? Okay, so they only want the dimensions. They don't ask for the actual perimeter. But if you wanted to get the perimeter, you could, because you could just go 2 times this plus 2 times that, which is basically 4 of these. But it's not asked for in the problem. All right, move on. I'm worried about my battery running out here. Okay. Consider the following problem. A box with an open top is to be constructed from a square piece of cardboard 3 foot wide by cutting out square from each corner of the 4 corners and bending its sides up. Find the largest possible volume such box can have. All right, so let me draw this on a different page. We have a square piece of cardboard. It's my best square I can get there. Then it's 3 feet. Is it 3 feet? It's 3 feet wide, so it's square, so 3 feet by 3 feet. What we're going to do is we're going to come in here and we're going to cut out the corners. So whatever we cut out of the one corner, we have to cut out all corners. Once that's cut out, we're going to fold it along this line, this line, this line, this line. When we fold the sides up, we will get something like this. I'm not asking you to be an artist here, but this will just give you a better idea of what's happening. Okay, so that's what happened. We folded things up. Now, to do this problem, what we'll do is we'll say that the amount that we cut out, okay, so the width of this cut is something we don't know. It's x. And that means that this is also x. And same thing for each corner, x, 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 x. So when we fold up the sides, let's take a look at this edge right here. How long is this edge? And that corresponds to this edge of this. Well, that length is the total 3 feet it was, but then we took off x and took off x there, which means that this piece is 3, take away 2 of those x's. Okay, that's what this distance is right in here. And the same thing goes for this edge. This edge was also 3, and then we took away the 2 x's there. So take away 2x, that represents just this piece. Now the reason I'm doing this is because I'm trying to find, going back to the question here, trying to find the largest volume that this box can possibly have. So depending on the size of this x, I could have different shaped boxes. You know, if I make a real big cut, then my box would be very tall, but not as wide. So just by varying that cut, it changes the dimensions. So we're trying to find the maximum volume here. And volume, of course, if this is my box, if this is length and width and height, volume is always length times width times height. For us, the length and the width are the same. This is your length, this is your width, okay? You can say that's this and that's that. So what we have is 3 minus 2x times 3 minus 2x, that's length times width, and then times height. Now notice that when we fold up that edge, this right here corresponds to these two sides right there. So that is our x because that got folded up. So this piece right here is x. So that means the height is x. So I put an x here. And now what I'll do is I'll notice my volume here can be distributed, right? I'm going to get this is all a function of x. I'm going to do a little foiling here. And I would get my volume is now a function of x. It is 9, let's see, minus 6x, and then minus another 6x, and minus 12x. Then we have plus 4x squared, then all times x. Distribute that last x through, and I'll put it in descending order. 4x cubed minus 12x squared plus 9x. This is my volume function, my x. My x is actually bounded. The smallest the x can be is 0, because then it wouldn't make sense. We wouldn't have anything. The biggest the x can be is a little tricky because this x is this side, but it's also this side, so you could only meet in the middle. So the largest it could be here would be the 3 over 2, and then this side 3 over 2. So x is between 0 and 3 over 2. And so what I'll do now is I'll take my derivative. Derivative of this is 12x squared minus 24x plus 9. Now I'm now going to set my derivative equal to 0. And that means I'm going to take 12x squared minus 24x plus 9. Set it equal to 0. Let's see, I can divide through by a factor of 3. So we get 4x squared minus 8x plus 3 equals 0. This is a quadratic equation. So there's different ways to solve this. You could probably use quadratic formula. You could try factoring. I don't think, will factoring work? 12, yeah, that will work, I believe. Let's see, let's try this. 2x, 2x, 3, and 1, negative and negative. See what happens here. If we multiply that, it's 4x squared minus 6x minus 2x, that's minus 8x, and then the last two multiply. So that's it. Now you could also use quadratic formula, and you get to the same answers, but we set each of these equal to 0. You get x is 1/2. You get x is 3/2. And so now what I'm going to do is just notice that x is 3/2 actually is one of my endpoints, and x is 1/2 is in there somewhere. So there's two ways to approach this. I can look at this as if it's on a closed interval, or I can do the open interval method where I just do a number line. I think I'm just going to do a number line real quick to check that at 1/2 is where I have the maximum. So if I plug in some points, so if I plug in, let's say 1/4, plug in something bigger, but I can't be bigger than 3/2, so how about, like, I don't know, 0.6. I plug those into the derivative, so plug them into here. So that might be a little bit tedious, so why don't instead we plug them in here? Forget that that's a 0, just plug them in. So if I take this and I plug in 1/4, so 2 times 1/4 minus 3, what would I get here? Well, 2 times a 4th is a 1/2. 1/2 minus 1 is a negative number. Times over here, 2 times a 4th is a 1/2. Times a negative number, you get another negative. Negative and negative multiply to be positive. That means that my volume function is going up here. And if I plug in 0.6, same way, 2 times 0.6 minus 1 times 2 times 0.6 minus 3. We're hoping for a negative number here. So 2 times 0.6 is 1.2. Subtract 1, that's positive. 2 times 0.6 is 1.2 times or minus 3 is negative. Positive times negative is negative. That means our volume goes down here. That means we have a maximum here. And so if x is equal to 1/2, we should get a maximum volume. Now, does the problem ask for the actual maximum volume? Let's see. Write the volume as a function of x. They do this. They ask for some stuff a little bit different. Write the expression of volume in terms of x and y. And I'll let you kind of, I'll look at the solution for you. That's not important. What's important to me is you getting to these last two answers. Finish solving the problem by finding the largest volume. So yes, they do want the volume. So remember that the volume was actually x times y times z. I'm sorry, length times width times height. So this is our volume equation right here. All we have to do is plug in 1/2 for x into the whole thing. So I think I'll do it right here. Our maximum volume, volume max, will happen when x is 1/2. So plug 1/2 in right here. Half of 2 is 1. So we get 3 minus 1, that's 2, times, now we already know half of 2 is 1, 3 minus 1 is 2, times, and then over here we plug in 1/2. So you get 2 times 2 is 4, half of that, that's 2. And was the measurement in feet? Yes, it was. So 2 cubic feet is the maximum volume that you're going to get. I will take a look at their answer so you can maybe see those parts for the intermediate steps. Wonder if they're going to give you a picture. Yeah, they kind of give you a picture. And they call this piece y instead. Okay, so here it is. Let you take a look at that, but you see we get the same thing. They do a closed interval method, so all they did was they checked the endpoints. They plugged the endpoints into the original function, not the derivative, and then they also plugged in the critical number, which was 1/2, into the original function and got 2. So using closed interval method versus open, kind of your choice there. See how many problems I've got left here. One more? 2 more. All right. I don't think, I'm really skeptical if my battery's going to last this long, but I'm going to go for it. Find the point on the line y equals 3x plus 4 that is closest to the origin. You know, I think I'm going to work through their solution here. You think that's going to work? Let me see. Okay. The distance d from the origin, which is this point, to a point, now let me explain what this point is. Since y is always this coordinate, I can replace the y with that equation. So I just heard something weird on my headset. It's still going. Let me make sure it's coming out on my video. Yeah, my audio is still there. Okay, so what we had is we had the origin, and then we have a line here. This line is somewhere up here, like that. We're trying to find the point on that line that's closest to the origin. So it's obviously not here, and it's not here. It's somewhere, but any point on that line can be written x, y. But because they give us the equation on the line, it's written x, 3x plus 4. Now, the distance between 2 points, so these are 2 arbitrary points. Well, not arbitrary. 0, 0 is not arbitrary, but we have 0, 0, and then we have an arbitrary point on that line. The distance between any 2 points you can find, go back into your college algebra book or something, look it up on Google. Distance between 2 points, if this is x1, y1, x2, y2, distance between 2 points is square root of x2 minus x1 squared plus y2 minus y1 squared, or there's other variations, but that's basically it. So I'm taking, I do that, plug in, I get this. X minus 0 squared is just x, and then this right here is 3x plus 4 squared. Now, whenever we have a problem like this, trying to figure out minimum or maximum distances, it's always easier to, instead of looking at d, look at d squared. And the reason why is because it gets rid of the square root. So if I square the d, we'll call it s, then the square root goes away, and then you get this. So we want to know when that is the smallest it can possibly be. So all we do is take the derivative, which is here, and then we simplify that derivative. We set that derivative equal to 0, which means that when you solve this equation set equal to 0, you get -6/5. And then now the way they're doing is they're going to do a second derivative test, which is fine. Second derivative test will tell us if this is a max or min. So once we have x is -6/5, we're going to take the second derivative. Second derivative of that is 20. since that is a positive number, what we have is that for this s function, at negative 6/5, our derivative is 0, which means slope of the tangent line is flat. But then our second derivative is positive, which means second derivative is our concavity, which means that we're concave up there, which means at that point must be the lowest point on the graph, which means it's a minimum. And then, so once we conclude it's a minimum, we can take that point, figure out what y is. To figure out what y is, just take that x value, negative 6/5, plug it into the x right there and compute that. And that's your 2/5. Now, just for the sake of being clear here, you could have, again, done a number line. You could have said negative 6/5. You could have tested points. If you like that method, you would have shown that to the left it's going down, to the right it's going up. Your s function is going down, s function is going up, which means that you had a minimum value there. All right, a Norman window. Due to time constraints on my battery life, I'm going to show you the answer to this. And I believe I worked through one of these in class in one of the videos. So this is what a Norman window looks like. So you draw a rectangle, and then you make a circle up here, which means that this distance is half of the distance all the way across, right? This is like the diameter of the circle, so half of that's the radius. So the main thing is just trying to come up with a formula for the area of this. So the area of that is x times y, which is, what do they want to find? Maximum area, here we go. So the area here is x times y, and then plus the area of this half circle. So remember, the area of a circle is pi r squared. The radius of this is this. So pi r squared would be pi times x squared over 4. So pi times x squared over 4 is what you can get here. But remember, that's the area of a whole circle. We want to cut it in half, so you put a half in front of that. So what we do is we try and find the maximum of this. So the problem here is that we have a y. So to get y, we had to go back to the constraint. And the constraint was that the perimeter of the window had to be equal to 30. Now, perimeter of this window is x plus y plus another y, so x plus 2y. That's this part right here. And then, remember, the perimeter of a circle is the same as circumference. And the circumference of a circle is 2 pi r, but we're only going halfway around, so it's just going to be pi times r. So this is pi times r. So that equation right there is our constraint equation. And you can solve it for y like this, moving things around. And then once you get that y, you take that y and you plug it into this area function, and then that goes right here. And then you have that part right here, which came from this. And now that's the thing that you're going to take the derivative of. And then from there, you can go ahead and either use the second derivative test or, again, break up that number line. See how you do with that. That's it for now. I won't be able to post another video for a while until I get my batteries charged on my headset.